Hello, welcome to the almost never-ending Lecture 1. It occurred to me that there were some important things I needed to add to this introductory series of lectures about research methods and data and so forth, because we'll be talking a lot about numbers in this course. We'll be looking at a lot of graphs, using terms like median and decile and quintile and so forth. So I just want to give you all a brief introduction to that part of it and a few statistical terms, as well as an overview of the kinds of how it is that social scientists come up with this data that will be presented throughout the course. How do they do that? How do they know that their data is reliable or representative of what's going on in the world? So just going to go over some of that. It seems like more than it is. If you look at the PDF, I'll try to get through that as quickly as possible. A lot of the graphics I'm using as examples in this lecture, you're going to see again in the lecture on poverty, and then again on gender inequality and racial inequality. You already have, in a sense, but I've been working on updating the poverty and inequality lecture so that it's a bit more current, and that's taking a bit longer than I thought. There's some data that just is not really easy to track down in a reliable from a reliable source. So I'm going to share my screen now, and we'll get through this as quickly as we can. All right. I'll be going through, as usual, a slideshow. Okay, just some decorations. Here's someone completing a survey, filling out a form. That's a lot of data that sociologists, political scientists, economists, and other social scientists use to draw conclusions about what's going on in the world come from this, from someone providing the information in an objective way on a form, or they're interviewed, or something similar to that. And often this is the kind of data that you can do statistics on most easily. Here's an example of something that we won't talk much about. It's just included for reference: experiments. We're seeing more experiments in the area of the social sciences that involve economics and decision theory, things like that. Not so much, there aren't many experiments dealing specifically with social problems, because you can't really do an experiment where you vary the conditions with someone's upbringing or their educational opportunities and so forth to see the differences in outcomes. This is a scene from a famous experiment, the Milgram experiments on obedience, which were highly controversial. If you want to see a dramatic rendering of that, look for a film that I believe is either on Amazon or Netflix. It flips back and forth between them. Experimenter. It's a very good film. I show it in my face-to-face classes. I'd show it here if I wouldn't be violating several copyright laws. So I encourage you to take a look at that. Towards the end of this lecture, there's also a link to some information about it, and as well as another experiment that is pretty controversial, the Stanford Prison Experiment, also the subject of a recent dramatic film with Jared Leto and some other actors you would probably recognize. So, excuse me, not Jared Leto. I skipped that. You would recognize him. Anyway, so the scientific method. There's the term social sciences refers to a cluster of disciplines, of academic silos, in a sense. They're not quite as siloed as many bureaucratic organizations, but they have specific approaches, specific interests. They work on different sorts of problems. Many of them consider what they do scientific. They at least make an effort to mimic the methods of the natural sciences, by which I mean chemistry, physics, biology, etc., insofar as they want to do research which someone else can repeat and get the same results, meaning replicate the research. The issue of replication is controversial also, particularly in psychology, which is not strictly a social science, but it overlaps several of them: sociology, anthropology, economics. Often people distinguish between the social and the behavioral sciences. Behavioral would include psychology, perhaps some others. So you've probably been through the scientific method already, these steps. This is not actually how most scientists do their work. They'll often have a hunch about something, and there are some research methods which frown upon doing literature research, but that's uncommon. Grounded theory is the school of research that does not believe one should do a literature search, because that is going to bias your hypotheses. So, but typically you do at least the literature search before publication. So typically this question may come from an assumption from a larger theory, but often that's not the case. So you might, let's say you have, based upon a theory, you believe there'd be a certain relationship between educational level and income. So that would be the question you'd be attempting to answer. Does the data support that claim? So you'd set up you design a study to gather information from some source, do an analysis, and draw conclusions. And then you would hope to report the results in the form of a publication that would add to the body of human knowledge, or at least click off a few boxes as for having publications when you come up for tenure review for that dwindling number of faculty members that have tenured positions. In sociological research, there's two broad kinds of research: qualitative and quantitative. Qualitative involves just examining the qualities of things as opposed to a numeric sort of analysis that's amenable to statistical methods. So that would include interviews. It would include participant observation, which was the other photo on our title slide I forgot to mention. A sociologist doing participant observation try to understand the lives of unhoused / homeless booksellers in New York City at a particular point in time, recent history, slightly before the September 11th incidents in New York City. So a participant observation involves these researcher actually becoming a part of the lives of the people they're studying. You can have non-participant observation where you're just observing in a distance, you don't really interact. Ethnography is usually it's a publication that details the whole way of life of a particular group of people. This is relevant to a lot of social problems. You might do ethnographic studies of the poor or of different racial and ethnic groups to explain what their life is like in detail. Interviews can be open-ended or closed-ended. An open-ended interview is, well, a closed-ended is where there are preset, pre-structured questions. You pick one of several possibilities. Open-ended is where you can talk at length. You can collect more information. A person can expound upon that. Often you might see something like this in a form, it said other, please describe the other. You've probably done this online many times, trying to uninstall a bit of software. That other becomes data for them. Everything you do online that involves apps and social media becomes data for someone. You're providing information, you're doing work for free for the big tech firms, but I'll leave that there. Case studies are going to be common in social problems research. Content analysis, historical comparative, not quite so much, so I'll leave that there. I basically mentioned this already. Well, quantitative research, analysis of numerical data using statistical methods. So pre-coded closed-ended interviews would be, that's pretty commonly the sorts of data gathering you would find in a survey. A survey is basically you're just collecting answers to questions from a sample of the population. Now, a sample is a subset of the total population because it would be expensive and not very effective to do a survey and get everyone's input in a country the size of the United States, for instance. By the time you got done with the people that were alive at the time of the study began, you would have more people coming in. It would be never ending. So you design a sample that's intended to represent demographically and in other ways the overall population. And then you take what you find from that sample and you extrapolate to the larger population. The validity of this extrapolation varies with a number of factors I don't need to go into. I have to tell you, I am kind of a data nerd. I like doing statistics. That's part of my day job. I also am more, though, into theory, so I will burden you with more theoretical perspectives on social problems than perhaps many would, or the unknown author of our textbook has. So again, the quantitative, quantity, there's a number involved, a count of some sort, or a value of a variable. A variable is an item of interest. It could be income, and obviously it varies, you know, from nothing to billions and billions. Height, weight, age, those are all variables. Gender is a variable as well. It can be coded numerically, so it can be run through statistical ringers as well to control for gender in certain sorts of analyses. So data literacy, I think, is very important in today's world, because not only are we bombarded with streaming media and news from a variety of reputable and less than reputable sources, a lot of this news that we get may have new claims about the number of something that exists or the percentage of people experiencing a certain condition or phenomenon. And the language that's used to describe that can be misleading at best and deliberately deceptive in many cases. So I'm going to lead you through a few little things to consider whenever you come across claims about data. Now, most of the data and graphical display of data you're going to see in this course is from fairly reputable sources: the United States Census Bureau, General Social Survey, other researchers that have assembled data from these sources. I myself spent quite some time yesterday trying to update a graph using Census Department data, and finally surrendered. Something had been changed, but I'll mention that again in a minute. So statistics is just the science of learning from data. And within the field of statistics, you learn about all data collection and how to design a sample and interpretation of different statistical tests. There are many, many, many. Data is simply just information. It's very broadly defined. A variable, I already described that. Now, in a statistical model, which is often what is created to test a hypothesis being something you infer from a theory, that if that theory is true, this should be true too. And you test the hypothesis. You never prove it. You either reject it or you fail to reject it with statistical methods, if that's the way you're going. Basically, so you might construct a complex model that relates several variables. I mentioned, let's say income, your income at age 50. You might include gender, race, ethnicity, education, all those things, these individual things you would call the independent variables because they vary, okay? Whereas the thing you're studying, income at age 50, is the dependent variable because you're in your model, it depends upon the values of these other things. And you would do some sort of a statistical test with this model. There are many type ways to do that. And you get some output numbers that tell you which of these factors was statistically significant within your model. But it tells you really, can you reject this feature as significant? It doesn't tell you it is real, but is there evidence that it is not? So, and when you reject the hypothesis, they call the null hypothesis, that there's no difference, there's no connection between any of these things that I just mentioned in that example. That's the hypothesis you're actually testing, that there's no difference, that any differences you see are just due to random variation, chance. So when you reject it, what you're saying is the differences are too big to be accounted for by random variation. I may have gone beyond where I meant to go, but there's two broad kinds of statistics. Descriptive, that's just fairly simple calculations, things like the average, the median, or the variance, which I'll explain in a moment. The median more than the variance, but we'll get to that. Then there's inferential statistics. This is where you're doing tests to see if some pattern that you believe might exist in the world can be assumed to exist, or is this pattern, the pattern that you think should be there, not really reflected in the data collected in the real world? What you see in the real world could just be random variation and no kind of pattern at all. Here's a few examples of those various tests. If you are in a medical field or you're planning to go into engineering or science, you're going to encounter definitely t-tests and regression analysis, possibly not factor analysis or some of the more complex. It depends upon how far you go and where you're going. Oh, sorry. Okay, means and medians. A mean is an average, so I mean, if you want to know the average number of squirrels in 5 trees in your yard, and they all are in nests at one particular time, you might, well, that's a bad example. I'm just seeing a squirrel out my window at this moment, so it's okay, the average number of automobiles that a household owns. You go to, like, say 10 households, count the number of cars in the driveway. You add up the number of cars, you divide by 10, that's your average. You've all done this before. But depending upon the distribution of the data, the average may distort what is actually going on. Many times in the media, and I'm going to show you an example in just a moment, they'll talk about an average when what they really mean is something called a median. Okay, the median is the midpoint of the data. The average is what I just told you. You add everything up and divide by the number of units that you got this total from. So you need to know, be alert for the difference between averages and medians, and particularly when an average can distort what's going on. So here's an example. Let's say you have a town, 500 people live in a town. What's the average income in that town? Well, you add up everybody's income, you divide by 500. Let's say 499 make $10,000 a year, but one makes 10 million. If you take that average, it's about $30,000. And you'd say, okay, the average income in this town is $30,000. That's not so bad. But only one person makes more than $10,000. So that's not really, that 30,000 average doesn't tell you what is really up in that town. A better statistic is the median. I already mentioned that it's the midpoint. It's the point at which half the numbers are above, half are below. So in that town of 500 people, you line everyone up from the lowest income to the highest, and then you see who's in the middle. Now, the person in the middle is going to make $10,000 because you'd have to go all the way to the end to get Mr. or Ms. 10 million a year, who probably owns a factory that everyone else is underpaid working at. So you'd call that 10 million value an outlier. Okay, so the median is a better estimate when you're talking about things like income that are not distributed in what we call the normal distribution. The normal distribution is that bell-shaped curve I'm sure you've seen before. Here's an example of a graph that uses the median. We're going to see a lot of trend graphs, trends over time and something. You see along this axis, which is called the x-axis. If you took algebra, you may remember that, is the year. This is the median household income. And this is income adjusted for inflation. So you can compare one year to the other. And you see in 2006, well, let's say 2007, the median income was $61,000. And then we had this period, the Great Recession, it was called for a while, although we're going into a greater one now, where incomes went down. People lost a lot of money in jobs. And it kept going down until about 2011 and flattened out for a while, down around 57,000. So that's like an 8% drop, really. And then it began to climb in 2014, and it climbed, and it last 2018, 61,937. But it's barely above where it was in late 2006 or early 2007. If you look at hourly wages for manufacturing workers, it's taken even longer to get back to where people were at their peak, their recent peak. So median income, this is 2018, the median income now is not much different than that because again, we're talking about the midpoint. Many people have made a lot more money in the past few years. A small group. We'll be talking about economic inequality, and when we have the chapter on poverty, I'm expanding that a bit to include those issues that don't specifically include people who are poor, but people who are just in the same spot year after year after year, but they are getting by. So, by the way, at this point in time, the median income in Houston, Harris County area is getting closer to, it's not on this chart. Well, I think it's around 40. Let me table that, but it's much lower than this. It's maybe 57,000 in Harris County, or in the state as a whole is lower, but there is an uneven distribution of income in the United States, state by state. You'll see that when I talk about poverty and income inequality. Here's an example of confusing a median with a mean. And I was just looking for some information, charts for, and here, so average income by education. You see that term average, okay? And it's related to student loan debt. Well, he was thinking about student loan debt and that it's 1.6 trillion at the time he wrote. And this is not a formal scientific paper because you don't see expressions like holy crap much in the peer-reviewed journals. And he took this from the Census Bureau, I believe. Did I not include enough of that graph? No, I did not, but this was from Census Bureau data. But look here, it's not the average, it's the median. So, oh, by the way, the average income in the United States, I showed you it was the median back here, about 62,000. I'm not sure, I didn't find it for 2018 yet. That's where I found the student loan education versus income graph. But in 2019, it was 89,000. So that's the difference in the United States between the median, the point at which half make more, half make less, and an average. So that's almost 30, that's 50% higher than this median, 90,000. So anyway, so here they've confused that. Distribution, as I mentioned, here's the bell-shaped curve. These statistical methods are kind of, a lot of them are really wedded to this notion. That's how they determine whether what they're seeing could be the result of some systematic pattern or whether it's a result of chance. So how far out of this bell does your result have to be to say, no, it's not part of this, because this is considered random scatter and normal distribution. Half, again, half above, half of the median and the mean is the same, are equal in this case. It's also something called the mode, which is just how many, this number would be, let's say, income. And then you would, how many people, which income is most common? That would be the mode. So it could be, but you don't usually see this distribution in a lot of cases. Definitely not in environmental data, which is where field I work in. I never mentioned that about myself in the beginning, in the introduction. I've been working in the environmental field for a long time, but I also have a sociology and a public administration master's. And there is a field called environmental sociology, to which I apply all these things in my regular sociology classes. And I will in this class as well. So you see there's a spread. Now, how big a spread there is the term you call the variance, okay? If this is let's say this is not spread so far and the curve is all like that, there's low variance because there's not a big difference between the highest and the lowest. If it's flattened out, there's some high variance, and variance is a number that's important in your statistical test. Here's a distribution that's like, this is income. This is the one I was trying to update. 2010 distribution of annual household income in the United States. I can't find anything more recent that looks like this than 2010. I think however they changed the data they're providing has flummoxed more people than me. So this one's all over the place. This again is from the Census Bureau Current Population Survey. That doesn't look like that bell shape. What you have here is a histogram, and each of these bars represents a certain range of values. This one, and if you zoom in on this on your PDF, you'll be able to see this. You blow it up. Under 5,000. So these are households where their annual income in 2010 was less than $5,000. This axis, the y-axis, it's labeled percent of households. So 3.5% of households in 2010 had an annual income of less than $5,000. Each of these bars is $5,000 range. So this is 5 to 10, 10 to 15, 15 to 20, et cetera, et cetera. And you see what's happening here. It starts dropping and dropping and dropping, and then, oh, there it's going up again. If it was updated, I think these parts would be taller. People at higher income levels have seen their incomes increase at a much higher rate than those at lower income levels. For, as you saw, the median income has not really increased over time. But the top 10% of incomes, reported incomes greater than $135,000. Now, the data I was working with didn't go this high. It only went to 150. And the reason you don't get the actual number, like 6 billion, you need tax records for that. This comes from survey data, and people check a box, and in this case, it was 200,000 and up was the last box on the list, or the last entry made by an interviewer. So this is about 4% of households here, these two groups that have let's see, what percentage? Oh, that's the percentage. Never mind. They have more than 4% of the total income distribution. Cause and effect. You're going to hear a lot about this in this class, and if you read the text, something is likely to cause or may cause another thing. It's difficult to be certain about that. There are some really advanced statistical methods that I'm not good with that can get you closer to being more confident you're finding an actual cause and not what we call a correlation. And in social science, it's not like chemistry where you have an equation and you can if you have so many grams of chlorine and so many grams of hydrogen, you can predict how much hydrochloric acid you're going to get from the reaction, and it will be correct. There's nothing like that really in the social sciences. Any prediction involves probabilities, and that's why statistics is so important. Correlation is often confused with causation. Things can be correlated, but they're both caused by something else. The one doesn't cause the other. Correlation just means one goes up, the other goes up, or whenever one of these variables, these features goes up, the other always goes down. And again, it's not, in social sciences, it's not going to be absolute. You're never going to. So you evaluate these situations statistically. So a case where one thing goes up and the accompanying thing goes up as well, some might say, well, it's causing it because that's the fallacy of post hoc ergo propter hoc in a sense. It follows, therefore it's caused by, although that might involve time. This doesn't necessarily. If they both go up, there's a positive correlation. If one goes up, the other goes down. You call that a negative correlation. But you determine whether or not they are truly correlated with statistical tests that will tell you how likely what you're seeing is just due to random variation. But it doesn't mean that either one of them causes the other. It just means they're correlated. That's all you can conclude usually. Here's an example of these two kinds of correlations. These are actual. This is actual data, so years of education, annual income. Then for this one, a negative correlation, dental problems requiring care, annual income. People with more money go to the dentist more often. They have fewer dental problems requiring care. They're getting more regular care twice a year, as usually is recommended by dentists. Spurious correlations are those that it's there, it doesn't make any sense. I'm going to show you some. Nobody can figure out what theory would show they should be correlated. The mantra, which has been common in the social sciences for a long time, correlation is not causation, does not equal causation. Again, there are some techniques that people have developed where they're trying to overthrow this claim, but the success of their campaign is debatable. A lot of the claims are coming from people who are using very sophisticated types of machine learning and neural network models, and which I need not go into. You've heard the term big data, for instance. That's not really what I'm talking about. Big data is just, for instance, taking everyone's online activity, the websites they go to, the products they search for, and finding correlations, because that's really all they care about. They don't care about the theory. They just want to know if it's more likely that a person with these features, this age, this gender, this race and ethnicity, this level of education, is more likely to buy this product than someone who isn't, and then they will target their ads to the people who are more likely to buy it, and they don't care why that is the case. So, and the larger your sample is, the more likely it is you're going to find a pattern that you can say deviates from the random scatter. All right. Here's some examples of confounding variables. That's something that's correlated with both these other two. I put independent and dependent because it would look that way in your little model, but that implies causation. So that's a bad, don't memorize. It could, but not necessarily. This is the case where you have a more sophisticated model. You're trying to predict something, okay? But there's a variable that you forgot. You don't have it in there, and it's a factor. For instance, if you don't have gender in a model that predicts how often do you go hunting, depending, or something like that, something which there's a gender difference in participation in a particular activity, something like that. So here's the classic example of where you have confounding variables. Ice cream sales are highest in the summer. So's the murder rate. They're correlated, but they're not causal. Would you want to say eating ice cream causes murders? Or would you want to say that murders cause people to want ice cream? No. They're associated with, they're caused, so to speak, by the same thing, by hot and long days. It's hot, you want some ice cream, or it's hot, the day is long, you have more time to get into mischief, problems. Stress from heat-related issues may lead to shorter tempers, more angers. So you can say they're responding to the same thing. These are some real, here's an example of big data research here, where some actual correlations were found, and these are spurious. There's no reason why, well, there is. Some of this is, there's a variable not measured. As comic book sales have gone up, there have been more computer science doctorates have been awarded. Does this mean that reading comic books makes you more likely to go to graduate school and study computer science? Well, probably not. But the economy is expanded, the population is expanded, so that's what is driving this. Okay. Injuries relating to falling televisions is correlated with undergraduate enrollment at U.S. universities. Now, I have found one student who said they decided to go to college after a television fell on them, but only one in all this time. What's happening here? Televisions are getting bigger over time. Population's getting bigger, more people going to school. The older tube type TVs, if you had them anywhere they could fall, you didn't plan well in putting your television up. But the flat screens, they don't weigh very much, but if they're high enough and they're mounted improperly or they're shaky, they can fall from a distance and injure someone, particularly a small person. And this is a good one, tornadoes and shark attacks. So, graphs. You just saw a few graphs. I'm going to tell you about some right now in case you need to know. Okay. Usually they're either trend lines or histograms. The trend lines show change over time. The histograms show the distribution. And you can slice these up and look at, and see trend lines for two different groups. So, all right, here's both of those where they're sliced. This is a trend line, the female to male earnings ratio. Women in the year 2017 made 80.5% on average of the earnings that men did in comparable employment. Year-round workers, 15 years and older. This trend is from 1960 to 2017. So it's improved, but there's still a big difference. They've also, these blue marks show the recession. Now here it's just split. Now if you get your calculator out, you'll see that this number is 80.5% of that one. So there was a bigger gap back here and it began to narrow, and it hasn't really changed all that much since the late 90s. A little bit, but so. Anyway, these are trend lines. On the x-axis, you have the year. The y-axis is the percentage. This is a ratio in percent. male over female, or female over male, times 100. This is actual earnings. This is in thousands of dollars. It is in 2017 dollars. So that's the standard for comparison. So in 1960, women on average, the median, excuse me, I said average. Pardon me if I said that. It's easy for anybody to confuse that. Sometimes you will see an average in this stuff, but this is median, the midpoint. So in 1960, half of women working full-time year-round, 15 years of age or older in 2017 dollars made about 24,000, whereas men made about 40. And I need to retract when I mention comparable types of work. I don't think that is a factor here. That's just raw income. So, and this would not include a woman that stayed at home to raise children. So that's not a factor. This is full-time employed women and men. Okay, here's a histogram. You just saw this. I explained that. These bars represent a little range of values, and this shows the distribution of incomes in the United States. Oh. Okay, here's another trend line where it's split by different ethnicities over time. Data on Asians only began to be collected in 85, it appears, and there is a gap here in data collection in some cases. So you can see what you probably, many of you probably already know, that there is that some groups make more money than other groups systematically. So again, here's the year. Here is the median income, and it's in 2018 dollars this time. That's, if you see real income, that means they've adjusted it for a certain period, and they do that by looking at what can that income buy, or a certain part of that income. What is the cost of a market basket of a certain number of items over time, and then you can, you know, how much of that can this income buy? I don't want to go further into that. Here's another histogram, and it's split out into different groups by age and by gender. Median weekly earnings of women and men who work full-time or on salary by age. This is just for the year 2018. Weekly earnings in current dollars, so that would be 2018 dollars. Women and men by different age. You see that it's a little bit different. Where are they closest? This is probably where they're most similar, in the 16 to 24 age group. Think about why that might be, and we'll get back to that when we talk about gender inequality. Here's a table which summarizes all these types of research methods. Survey research is a big part of what a lot of people do when they're doing research. I mentioned some of this before, often questionnaires, but may be open-ended where people can talk at length. Samples are designed. There are different kinds of samples, random. Everybody's got an equal chance of being surveyed. If the population, if everybody was the same, this would be perfect. And you do, so you may have to design it so it matches the demographics of the population you're trying to infer something about, and then you might create a stratified sample where you can make adjustments. You can weight the responses differently if you undersample or oversample one particular group, whether it's an age group, racial and ethnic group, economic level, whatever it might be. Some kinds of surveys, and you may have encountered these, are called convenience samples. Just someone's on a street corner and they give it to whoever walks past. Then there's snowball sampling. This is where you want to reach at a group that's hard to reach. They don't necessarily identify themselves. So, for instance, this might be you want to do research upon people who cook methamphetamine for a living. Well, they're not gonna. You can't put an ad in the paper and say we want to collect data from you. Come and see us. No, well, isn't going to work. So you might give the survey to someone you think might know somebody that knows somebody. Could be someone in jail at the moment. That's an extreme example. There are other aspects of human social behavior that people do not share widely, and you may want to try to get some information about that. So snowball, you give it to one person, they give it to somebody else, and maybe ask that person to give it to somebody else. Survey data, you don't always have to design your own research. There's an incredible amount of survey data online. I just mentioned the Census Bureau, the American Community Survey, but the biggest one, General Social Survey. Let's see if this is going to open and what's the screen is going to open in. There it is. They've been gathering data since 1972 on a very wide range of issues. They get all the basic demographics, age, gender, how many people in the household, income, employment type, education, all that. And then they will ask questions about other social issues or social problems, maybe that are usually important at that particular period of time. It could be gun control, it could be gay marriage, it could be the Cold War, military spending, those kinds of things. And then they may they'll vary those questions. They may go back 10 years later and ask those questions again to see how attitudes have changed over time. So if you're interested in this kind of thing, there's a little data viewer here, Data Explorer. You can just go in and start and, explore it yourself. I encourage you, if you're a data nerd, you might find this interesting. You can also download data sets of sorts. What I was missing from the Census Bureau was a code book, I think. And anyway, let me get out of this, back to our... The Census Bureau does a census every 10 years, is required by the Constitution, but there's the American Community Survey, which gets more detailed data on a different schedule. This is where I found the data I was trying to plot to update that income distribution. So I think there's a Data Explorer in here as well. View all data. Okay, data releases. Table and geography. So just changes, new and notable. Maybe this is what I should read. Slides. Okay. Well, anyway, we'll look at that. Spend a lot of time. Well, okay. That's something else, but it's not that chart. But it does show you. This is not bad. I should save that anyway. Let's go back and finish this stuff up. Okay. Some more about observational research. It's typically not quantitative. There may be some statistics they've gathered elsewhere to describe the population that they're studying, but they're more interested in what people actually think about what it is they're doing. What do they mean? How do they understand their world? And how does that relate to how one would expect them to understand their world? What drives them? What motivates them? So you really need to get closer to the ground level and understand their world from their perspective. That's part of C. Wright Mills' sociological imagination that I mentioned earlier lecture. I mentioned experiments have been controversial because well, I'll mention that in a second. Participant observations can also be controversial because sometimes you're with people who don't want a lot of their information out in a book. A very famously controversial study, The Tea Room Trade by Laud Humphreys in 1970, was about men having sex in public park restrooms. Now, that may seem an odd thing to do a study on, but Laud Humphreys was someone who had been a priest, a Roman Catholic priest in a diocese in Chicago where the gay community was centered. And in that time, in the 50s, they were not out. They kept their orientation private, known only to others with the same orientation. At that period, homosexuality was considered a mental illness that was treatable by the American Psychiatric Association. So, but Humphreys heard, as a priest, he heard confessions and he did counseling, and he became interested in the challenges that gay men face. So he decided he needed to know more, and he gave up the priesthood, went to medical school, became a psychiatrist, and went into practice. He found he wasn't learning what he'd hoped to learn, so he went back to graduate school, got a PhD in sociology, and a teaching position at Washington University in St. Louis. And this was really what he wanted to study. So he, over time, asked around and found there was a park where men would meet and have random sexual encounters. And he learned, he went down there and he learned before, that usually one person would be like a lookout who would stand outside and would alert the people inside this public restroom if the police were coming, because this was obviously illegal behavior at the time. Well, it still would be in a public setting. Or if a family group was coming towards the restroom, the lookout would let them know they needed to end whatever might be happening. So he volunteered to be the lookout, but while they were in the restroom, he went and wrote down the license plate numbers on their cars, had a friend at the Department of Motor Vehicles run the plate numbers, so he found their names and addresses, and then he went to their homes, dressed much differently. He was not recognizable, saying he was from the health department or something like that, doing a survey. Can I take a few minutes of your time? Yeah, come on. So he gathered all this other data about these men and published it in a book. He didn't use names, of course, but it was a bombshell. People had no idea that they knew nothing about the lives of homosexual men in 1970 for the most part in St. Louis, Missouri. The people of St. Louis, I mean, if you the image of someone who would be doing these things in a public restroom would be not very favorable in the public image, I would say. And he showed that they were really much like other people. Most of these men were married, had children, went to church, had regular jobs, but there was a part of themselves, a very fundamental part of themselves, that they could not express openly, and it had to be done in secret, at high risk. Please, I'll turn this on because first thing I'll have to do is share it's pretty short, but it's another participant observation that gets closer to what we're going to be talking about in terms of social problems. Here we go. Sudhir Venkatesh and his participant observation, published as the book Gang Leader for a Day.
In the late 1980s and early 1990s, there was a phrase that was used in the news a lot, the gang and drug problem. And we really didn't know what the gang and drug problem was. And Gang Leader for a Day is a book about my time trying to get inside the world of gangs, inside the world of drug dealing, inside the world of a poor community, to help people understand what life was like from the inside. The project started in a way that I could never have predicted and probably would never want to have happen again. I was asking a bunch of street gang members some questions in a poor community, trying to be a good sociologist. They didn't believe that I was a sociologist. They thought I was a rival Mexican street gang member, and they held me hostage in the stairwell for 24 hours. And when they felt it was safe to let me go, they told me, you know what, you really need to live with people. You can't ask them silly questions and hope you're going to get the real answers to life around here. I took that as an invitation, and I came back. I met the street gang leader, JT, and the book is really the chronicle of the journey between me and JT for the better part of 7 or 8 years. JT was kind of an anomaly. He had a college degree, he worked in a corporation, and he decided to come back to his neighborhood to run the street gang. And when I heard that part about his background, I wanted to know more. And we basically hung out with each other. And I think a lot of the ways in which I was able to gain trust and access was because of his own background as somebody who had a college degree, who had worked in mainstream America. And he looked at me as someone who might be able to tell his story to the rest of the world. It's not surprising when you think about the Robert Taylor homes why a big crack dealing gang would end up there. 40,000 people. It's a community that's very, very poor and desperate. They can't rely on the government. They can't rely on foundations. They don't have services. Politicians aren't listening to them. So sometimes they turn to the gang for help. So the very same gang that's dealing crack, that's really, really violent, also has money. And they turn it back to the residents by giving them small, bits of cash here and there to get to win their favor, basically. And so the book is really about that difficult place that people are in when they have to turn to a gang in order to survive. One day I approached the street gang leader, JT, and I said, listen, I don't see what's so difficult about your job. You basically stand around and give people orders all day. And he said, okay, well, why don't you try it? And so for one day, I became a kind of gang leader for a day. And I didn't shoot any guns or I didn't do anything illegal, but I had a chance to walk with him and see the kinds of difficult things that he had to do. Even little things like trying to find a place for 250 guys to meet, which is not so easy when you're doing illegal things. So it gave me a real inside look at some of the decisions that go into leading a 250-person crack-dealing street gang. I felt really blessed throughout my work because people really trusted me. They gave me a lot of access. They let me stay in their homes. They watched over me if there was periods of violence. This is a community that when you look at them on TV, it may seem like another world, like people that are really different than you and me. But I think what I learned is that we have a lot more in common than we think. And those commonalities really go across race divides, ethnic divides, and even social class. I never thought that I'd be learning as much from poor people in the US that I did, but at that stage in my life, that's really who helped me become a better person. The book is really about a community where people have to actually rely on a street gang to survive day to day. Imagine what that's like when the street gang becomes the person or the group that you go to get money, to get services, to get help. That's an awful way to live. And that's the way that a lot of Americans had to live, and some Americans still live.
Okay. All right. Skip that for now. Well, sorry about that. That was unexpected. Okay, I've already mentioned this about interviews, structure, and so forth. Milgram experiment. Okay, this involved Milgram. He become interested in why people obey orders to do things that are immoral, illegal, or downright evil, and he'd been stimulated by this thinking, this questioning was somewhat related to war crimes trials after World War II, where many of the Nazi functionaries at the death camps where 6 million Jews and 5 million mentally ill, developmentally challenged gypsies and communists were murdered systematically. Many times the people would say they did it because they were just following orders. And he wondered why people would follow, what leads people to follow these orders, what's involved in that. So he began a study of authority and how people respond to that when they choose to obey or not. The book that came out was called Obedience to Authority. Basically, people were tricked, in a sense, into believing they were delivering a series of increasingly powerful electric shocks to someone who eventually stopped responding to the questions that were part of this project they believed that they had signed on to participate in. And he found that 2/3 of the individuals in this study just kept going, despite the fact the person that they could not see, who was a Confederate with the experimenter, he was part of the subject of the experiment was the individual who believed they were administering these shocks when they were not. But nevertheless, they would hear someone shouting from the other room, "This hurts, let me out of here, I want to stop." And if they reacted at all, the experimenter in the white coat would just say, "Well, you must continue, and whether he likes it or not, he has to go continue, and so do you." And 2/3 of people just kept going and delivering these shocks. And many of them, it was traumatic for them. And they were being deceived. They weren't actually delivering any shocks. So it was very controversial, but if you're interested in that, watch the film. You can also see some of the original footage here. This may be longer than you're interested in, but basically he found that, what was necessary to get someone to it may just be as simple as wearing a white lab coat to get, in this situation, to get someone to harm other people for a small amount of money. Philip Zimbardo's Stanford Prison Experiment is also famous. He created a fake prison of sorts in a basement of the psychology department of Stanford University one summer to study how people, human interaction, and a number of other aspects of the prison and guard experience. So this is about a 20-minute video from some of the people who were part of the experiment, and it relates it to a historical incident you may not remember, but anyway, it's worth taking a look at. This is, I believe, the trailer for the film. And that is it, folks, for this. And I will get the lecture on poverty finally updated and up soon. And if you need to, go ahead and jump ahead to the race and ethnicity lecture. So I will also be setting up a class Q&A for tomorrow, probably at in the afternoon, maybe 1 o'clock, but I don't know what a good time is, but it will be recorded. So if you can't log in to ask questions, it will be available on the Canvas homepage. Now, if nobody at all shows up, I'll perhaps make a few announcements or things I think I need to clarify, but there'll still be something, I think. All right, see you later.